So for this first problem, this is number 47 on section 12-4. We're going to answer all these questions. So the first way you do it is this represents the height of a ball. S of t is the height. Isn't that what it says? The height S of a ball. I would think they would put H of t, but we'll call it S of t. It's thrown straight up with initial speed of 96 feet per second. And they want to see first, when does the ball strike the ground? That is how long is the ball in the air. So when the ball strikes the ground, it's right there. So its height, or S of t, would be equal to 0. Too much background noise here, sorry. I'm going to shut this off for a minute. All right. What the heck? Hey! Did you hear why the Scarecrow got a raise? Because he was outstanding in his field.
I told you that.
Oh, Austin told me that. Oh, Drew, that was pretty good. I've been using that a lot, and I've gotten some very good reviews on that one. All right, so anyway, the ball is going up and down. Okay, so when does the ball strike the ground? That is how long is the ball in the air. So you set this equal to 0. You could solve this algebraically by, from this equation, you could factor out a negative 16 t out of both of those. So if I factor out a negative 16t, this becomes t plus, no, not plus, minus 6 equals 0. See what I did? Because this times this will give you that, and this times this will give you that. And then you draw your little squiggly line, zero product property. So either t equals 0 or t equals 6. Well, this is the point where t equals 0, and then this would be the point where t equals 6. So it would hit the ground after 6 seconds. Okay?
Shouldn't that be t equals 6?
Yep, say equals 6, sorry. T equals 6. Yes. Okay, so that's how you answer the first question. The second question says, what is the average speed of the ball from t equals 0 to t equals 2? So in this case, what you're actually finding is if this is 2 seconds, right, you are finding the average speed between here and here. I don't want a pink line. So what you're finding basically is the slope. That's not a very good slope. I'm going to move it over. I can do that. How do I move that? Like this. There we go. So basically what you're finding in this one is the slope of this line, which is called the secant line, because this is change in time, and this is change in height, right? So by finding the slope of this line, you're finding the average speed between those 2 points. And the way I would do that is the slope of the secant line. So if you remember this, slope of the secant line is equal to s of t minus s of well, in this case it'd be s of 2, right? Minus s of 0, because these are the y values, over 2 minus 0, because those are the x values. You understand that? Yeah, maybe, no? So, because this is the velocity at this point, this is the velocity at this point, and this is the time that expires. So I'm basically taking the start height and the end height and the beginning height and dividing it by the time. So if I take s of 2, I believe that gives me 192 minus 64. Is that right? 192 minus 64. Did I do that right?
The initial height was
2. No, they're asking you what is the instantaneous. It says what is the average speed of the ball from t equals 0 to t equals 2. So this is the initial, not the initial height. The initial height is 0 in this case. If there were initial height, then there would be, like, say the initial height were 10, then there'd be like a plus 10 over there in this equation. But in this case, it's 0. And so s of 2, if I plug in 2 in here, I get 192, right? Don't I? 192. And if I plug in 2 in here, I get out negative 64. Tell me if I'm wrong. Okay? And so you get 192 minus 64. What's that? That's a big number, isn't it? 128. You get 128 divided by 2, which is 64 feet per second. Hey, so the next one asks you, what is the instantaneous speed of the ball? So in that case, that's at t equals 2. Oh no, at time t. So basically, what they're asking you to do is find the derivative, the instantaneous rate of change at this point. So we could do this algebraically, which you really should do using the limit process. But since I already told you the power rule, it's kind of cheating, but you can do that. So to do the power rule, I'm going to get a clean sheet of paper, a clean start here. Whoops, where'd we go? Where'd we go? So I'm going to, oh, it was this problem. So to do the next one, well, jump. Let's just go back. Let's just keep working here. So the derivative s prime of t, can anyone tell me how I find that using the shortcut? Do you guys remember? 2 times negative 16 gives you negative 32. This goes down by 1 exponent to t. So it's now t to the first. And this over here, the exponent of this is 1. So you go 1 times 96, which is plus 96, t to the 0, which is just 1. So this right here, s prime of t, that's the equation of the derivative at any time. Okay? So to find the any questions on that? Okay? Or you can use the limit process. So you go the limit as t, the limit as t goes to 2, s of t minus s of 2 over t minus, not 2 in this case, it'd be t of, as t goes to c. And this is why I didn't want to, t of,
goes to 2 for d.
yeah, but it get over t minus c, t minus c, or c minus t. Anyway, it gets pretty complicated, and there's a thing in the book where they actually do it. But we could do it, but we're not going to do it. So we're going to do the shortcut. So what is instantaneous speed at 2? You just take that 2 and plug it into that equation. So if I plug in 2 in there, I get negative 32 times 2 plus 96, which gives you negative 64 plus 96, which is equal to 32, right? Which tells you right exactly at t equals 2, right exactly at this point, the rate of change is equal to the speed of the speed of the ball is 32 feet per second, which is the slope of the curve at that point, which makes sense, right? Because what's happening to the ball as it goes higher and higher? It's slowing down. It's launched with an initial speed of 96, but then as gravity kind of works against it, right? It's slowing down. Okay? When is instantaneous speed equal to 0? Well, where on the graph is instantaneous speed equal to 0? Not down here. Right? It's going really fast there, right? Because it's coming up. So where is it equal to 0? At the top, yes. And that does come out to be 3. It's right in between, exactly in between 0 and 6. Now, if this were starting from a different height, it wouldn't be exactly at the middle. So what you could do algebraically, you just set the derivative equal to 0. So negative 32t plus 96 equals 0. And if you solve that, you get 32t equals 96. So t equals 3, right? So that's how you do this one. How high is the ball when the instantaneous speed equals 0? So in that case, now this is where they're kind of testing, you know, whether to plug into the original equation or the derivative. If I want to figure out how high the ball is, which equation should I plug into? into here, right? Because this tells you the height at any point. So now I'm going to plug in 3 into there, so I get 9 times how high is ball, so I'm going to get negative 16 times 3 squared plus 96 times 3, and that gives you some number. Who can tell me what that number is? 9 times 16, what is that, 2 something? 48, 1, I don't know. You get out the answer, okay? And then you can do that. Can someone do that? What do you get for that one? Did you get that one, Molly? What? 144. So how high is it? It's at 144 feet. And then the last thing says, what is the instantaneous speed of the ball when it strikes the ground? So then, which equation am I going to plug into? The derivative equation, because this is the one, this is giving you the change in height over time, so this will give you the speed. So I'm going to plug in negative 32 times 6, right? Because you want to know what is the speed right here. So I'm going to plug into my derivative equation, and I get 6 times that, which I believe is 192 negative, plus 96, which gives you negative 96. Is that right? Did I do that right? Okay. And that's feet per second. And you might ask, how can it be going negative velocity?
It's going down.
See, as it's going down. So as I'm going up, that's considered positive velocity, and if it's going down, that's negative velocity. Speed, okay, is the absolute value of velocity. So at speed, I would take the absolute value of 96, and I get 96. So its velocity is negative 96, because that indicates direction, but speed doesn't have direction. So maybe you drive your car really, really fast and backwards. You tell the policeman, no, I was going negative 100, not positive 100. And so I should not get a ticket. You should be giving me money because I'm going negative, but I don't know. Oh, it's the speed limit, it's not the velocity. Yeah, oh, that's a good one. Okay. So do you have another question on this homework? How about the one with the volume of the cylinder? Because you got that one. We're going to do that one with the limit process, but you could do it the same way. But I'd like to show you both ones.
I have a question about like counting labor. It said,
this one should be a good one to know how to do because it is on your final. Good. So I would pay attention, or one just like it is on your final. So I'm going to show you how to do this by the limit process, and then how to do it the cheater method. Didn't we do this in class? We did one just like this, okay? So you want to find the limit as the limit of V of R, okay? As R goes to 3, okay? And that's what you're doing in this, the limit of, actually, V of R minus V of 3. That's what we're looking for. Over R minus 3. So the change in the volume from some point R to 3 as R goes to 3. That's kind of what you're trying to find. And so the way you do that, V of R is, so you're finding the limit as R goes to 3 of 3 pi R squared minus V of 3. If I plug in 3 in here, what do I get out? Thank you, 27 pi over R minus 3, which just stays as R minus 3. And then you want it, if you try to plug in 3 in here, you're not going to find the limit. So what you do is you try to factor things out to make this R minus 3 cancel out. So you have limit as R goes to 3. What could I pull out of all these?
3 pi.
A 3 pi, very good. So you can pull out a 3 pi times R squared minus 9 over R minus 3. And then this factors to R plus 3 times R minus 3, right at the top. And then what I can do is cancel out this r minus 3. So this is gone, I factored it into this. And I cancel out this. Now I can take my 3 and I can plug it in there for r. So I get that's equal to the limit. That's equal to 3 pi times 3 plus 3, which is 6 times 3, which is 18 pi. Okay? And that's the rate of change. And if that's in feet, so I guess that'd be feet cubed per second or something like that. It's changing by a rate of so many feet cubed per second. So that's if you have a cylinder, right? And the radius is changing. How fast would your volume be changing? Okay, per unit of time, whatever the units happen to be. Okay? And then the way you would do that with the shortcut, if V of r is equal to 3 pi r squared, then V prime of r, which is the derivative of r, V prime of r is equal, you take this number, that's your variable. So you multiply this times the constant term, which gives you 6 pi, and this goes down to r to the first, right? So then if I want to take 3, because that's what they're asking you, how fast is that changing where r equals 3? What do I get out? What do I get out? 18 pi feet cubed per second. So this is the limit process. Yes, it's much more complicated, but it shows you where it comes from. Okay. So on the final, I'm not going to ask you. I'm not going to know what will you do. Okay. So as long as you know how to do it, you're going to do it. No, I'm not going to look at your plan. Okay. And Scantron, yes. But I might have a question like which represents the limit. Like they might have some ones where you have to show what I would do to find, you know. So like which is the right thing that I would do to find the derivative or something.